Hi students, in this video we will be solving question number 16 from the exercise 10.2 of the chapter straight lines, and this is a first PU syllabus. You go to playlist and look for straight lines, you will be able to find all the sums and derivations related to this chapter. Now let us check question number 16. The length L in centimeters. The length L of a copper rod is linear function of its Celsius temperature C. Check this word, linear function. In an experiment, if length is 124.942 when temperature is 20 and length is 125.134 when temperature is 110. Express L in terms of C. So this is the question. Let us understand the question now. There is a copper rod which has a linear relation with temperature. What do you understand by that? We all know that a metal expands when heated, correct? That is what is happening with a copper rod also. During an experiment, the readings were recorded like when the temperature was 20 degrees, the length of the copper rod was 124.942. But when the temperature was increased to 110, the length of the copper rod also has increased. What do you understand from this? The function is linear. When the temperature increases, length of the rod is increasing. You further increase the temperature, then the length of the rod is also increasing. It is a linear function. That is what we understand from this. One variable is increasing, the other variable is also increasing. So the function or the relation between them is linear. Have you understood why this word linear? You take the readings of the temperature and the corresponding length of the rod, you plot all the points, then you will be able to see that it is a straight line. That is why the function is linear. As temperature increases, length of the copper rod also increases. So it is very clearly indicating that this is going to be a straight line. We can use the equation of the straight line to find the relation between length and the temperature. Is this clear? So there are two readings of an experiment given to us where temperature has increased and the length of the copper rod also has increased. We have to express the length of the rod in terms of temperature. So can you tell me, out of length of the rod and temperature, which is the independent variable? It doesn't depend on the other variable. Obviously it is temperature, right? It is not depending on the length of the rod. But length of the rod is a dependent variable. It depends on the temperature. As temperature is changing, length of the copper rod is changing. So what do you understand from this? It is clear that temperature is independent variable and L, the length of the copper rod, is the dependent variable. By general convention, X is the independent variable. So I will be considering temperature along X-axis. And by general convention, Y is the dependent variable. So I will be considering length of the copper rod along Y-axis. Clear? Yes. The observation from the experiment, we get two temperatures and their corresponding lengths. So if you relate it to rectangular coordinate system and plot the points, what will those 2 points be? C, 124.942. Let's say it is somewhere here. Then 110, 125.134. It may be somewhere here. So you join those 2 points, then we get a line segment. So we have got 2 points after we have considered temperature along x-axis and length of the copper rod along y-axis. So if I am calling these 2 points as A and B, so then it will be line segment AB. Now we have considered temperature along x-axis. So this is x coordinate, and what is y coordinate? Length of the copper rod is the y coordinate. Instead of x, y, it is as good as writing C, L. Clear? X coordinate is temperature, y coordinate is length of the copper rod, C, L. Now to find the linear relation between temperature and length of the copper rod, this is a line segment. We can use these 2 points to find the slope of the line, correct? Slope of the line segment? Yes, we shall do that now. So we know the formula to find the slope of the line. M is equal to y2 minus y1 by x2 minus x1. So this is x1 y1 and this is x2 y2. Then it will be 125.134 minus 124.942 whole divided by 110 minus 20. So this M is equal to 0.912 by 90 is the slope of the line segment AB. So now if we find the equation of the line segment, don't you think we get the linear relation between L and C? Yes, that is what we are going to do now. We already know a standard form. When we know the slope of a line and a particular point on the line, we can use point slope form of a line, which is y minus y naught is equal to m into x minus x naught. So here slope we have just calculated. For x naught and y naught, we can consider any of these 2 points. Okay, so this is slope, and in this case I will be considering 20, 124.942. You can also consider this point for x naught, y naught. Now we will substitute these two values in the standard form. But there is one more thing to be considered here. We will not retain x and y. Why are we not retaining? Because along x-axis we have taken temperature. For y-axis we have taken length of the copper rod. So we will be replacing x and y by C and L. Is this clear? So instead of having an equation in terms of x and y, we will be having an equation in terms of C and L in this particular case. Hope it is clear, students. So for x, this x coordinate term, that is C, and for y we will be substituting L. Okay, we have done that. And now for x naught and y naught, this term, x naught and y naught. And for slope, we are substituting this. So what do we get? L minus 124.942 is equal to 0.192 whole divided by 90 into C minus 20. So this is the expression. Now express L in terms of C is the question. So we have to express L in terms of C. So we shall move this constant term to RHS. So it is L is equal to 0.192 divided by 90 into C minus 20 plus 124.942. So this is the required equation of the line. In general, we express equation of any line in the form of ax plus by plus c equal to 0. Here also we would have done the same thing, but they have asked us express L in terms of C. So we have written the equation in this form. Here you give any temperature, we will be able to find the corresponding length of the copper rod at that particular temperature. So this is the linear equation that we had to find, and we have found it. Hope the concept is clear. If you still have any doubt, please do mention it in the comment section.